Man, where's Summer at? Hey, you know where Summer's at? No one? Nope. Oh, she's in the restroom? Alright, cool. Summer, what are you doing? Shouldn't you be studying for physics?
Physics is irrelevant.
No, you're actually using physics right now. That hairdryer right there is thermodynamics.
What's thermodynamics?
Well, thermodynamics is everything that happens because heat is flowing from a hot place to a cold place. Nothing happens without heat flow. There are no exceptions. Did you know that?
No, so is that how this works?
Yes, so you are actually doing physics right now. Or using physics, actually. You know what? I'm going to show you the other laws of thermodynamics. There's 4 in total. Maybe we could cover a few of them. The first law of thermodynamics, but just to be sure, I googled it for you so I won't give you any false information. So right here it says that the first law of thermodynamics says that heat cannot be created or destroyed. This is also known as the law of conservation of energy. You know that, right?
Yeah, because heat can flow from place to place or change form. Heat usually manifests itself as the kinetic energy of the molecules of gas, liquid, or solid.
Well, yeah, but that's rather a limited view of what heat really is. Heat is work waiting to happen. Work will be done or wasted when heat flows from a hot place to a cold place. So really, heat is just work in waiting. For example, like if you take this aerosol can right here, you could consider this work in waiting, because if you apply heat to it, there's going to be a big reaction. Let's see if this works. That's thermodynamics. Alright, Summer, now it's time to teach you about the second law of thermodynamics, which is entropy. Why don't you explain what entropy is?
It's the measure of how evenly distributed heat is. The actual calculation of entropy involves some particles, differential equations, which can be simplified somewhat by keeping temperature of pressure constant and can be calculated by someone sufficiently skilled in mathematics.
That's true. And the result of countless calculations have shown every time heat flows from a hot spot to a cold spot, entropy increases. Every time heat flows from a cold spot to a hot spot, entropy decreases. A simple way that we could explain that is simply putting ice in hot tea. So why don't we just do that right now? And this tea is really hot, as you can see. So now what we do, we could add a couple of ice cubes to each glass of tea, and this will demonstrate entropy. If you could see here, the ice cubes will start decreasing in size and then eventually disappear. And just like that, the tea has cooled down and the ice cubes have disappeared due to entropy. So, now time for the third law.
Doesn't it deal with ideal engines?
Yeah, but it's fairly more complicated than that. It's actually really complicated, but let's Google it. Right here it says that the third law is that an ideal engine would convert 100% of the heat into useful work only if exhaust temperature were absolute zero. In other words, 100% efficiency is impossible. But most engines try to convert the most energy out of what they have. So, like, let's take, for example, a car engine. Right here we have a standard 16 valve Toyota engine, right? So why don't we go power it up? As you can see here, we have a standard engine of a car. All the bands, why don't you put it over there? All the bands are working in place. Now, like it was said before, no engine is 100% efficient because that is impossible. But engines such as these try to use the most out of its resources, the oil and the gasoline, to prevent the most energy. So today we learned about a few laws of thermodynamics and what thermodynamics is in general. Summer, what is it?
Thermodynamics is the branch of physical science concerned with heat and its relation to other forms of energy and work.
Yeah. Hello, I'm Sarah McLaughlin. No, I'm just kidding. No, in all seriousness, I think that people should take physics because it's actually a really fun class. You learn a lot of things that you didn't know before about the physical world, like such simple things that you didn't know before. It's kind of like, whoa, there's so much math that goes behind that. And there's a lot of projects too.
Yeah, you do hands-on things. There's the catapult, which is really fun. And then, like, you build a lot of things, like, it's you and your partner working hand on hand. It's not Mr. Burmaster helping you. It's using your knowledge that you learn from the class. And
she meant to say class, you guys. What are you doing?
Physics is irrelevant. I don't want.
Oh, hell no. Hell no. Really, Summer? You couldn't wait.
Okay.
I'm Roger Ramos, and I'm doing work. Hold on. Just check my. Oh, there we go. I'm doing work. I'm Roger Ramos, and I'm doing work. Hey, I don't know if I told you guys, I'm Roger Ramos, and I'm doing work.